Hello friends, today we start strip layout design basics. And what the purpose of strip layout design is to understand how best a designer can use a strip layout to make effective more tool design. And here we will discuss a lot of aspects and factors that influence strip layout design. So let's know who should go through this slide. Those are students who are studying in mechanical engineering, designers, tool makers, sheet metal manufacturers. So next page we go to contents. The first one is why we need a layout design at all. What is the purpose of studying this layout design? Is it really required or not? Factors affecting strip layout. What is called strip economics? Next is strip layout terminology. What are the terminology generally we use for strip layout? Type of strip layouts. First one is why need a strip layout design. What is the purpose of layout design? We can take a pencil and paper, we can make a tool, but why we need a very statistical study or very methodical study about layout design? What would it help us? Number one, to obtain a maximum strip utilization, that to 60% to 70%. Generally, when a designer design a strip layout, due to lot of constraints, due to profile, due to sheet thickness, due to clearance, so many factors, sometimes it is very difficult to maintain a 60 to 70% utilization. That then there is a chance the part cost will be higher. So number two is, when you design a strip layout, there are a lot of small punches, die profiles, wire cut, and punch holding, so many factors. So when you plan everything on pen and paper, you can able to see the punch and die position effectively. You can see the gap, you can see the metal condition before making mistake, before going for manufacturing. You can able to analyze your tool design on pen and paper or AutoCAD file or a 3D file. You can visualize. So that's the benefit you are going to get when you do a methodical study about layout design. Here I try to show a strip layout just for a explanation. I try to show some punches. So in this way you can put a punch or a die profile to see the actual metal condition. To manage a better productivity. What is productivity? When you make a component, you go to production side, make a tool, go to production side, you to run the tool and get the production. Sometimes it may not meet your production requirement. If you get one component for one stroke and you need 2 million components per month or per day, you need some lakhs of components, so you may not meet your productivity, you may not meet the numbers. So you cannot make mistake after making a tool. So better do the layout design and you can analyze, you can do a mathematical calculation about the number of production you need per day or per hour. So accordingly you make your layout, make your tool. So this is the way you can manage your productivity if you go for a perfect tool design layout. Better part cost optimization. What does it mean? Part cost means it's all about money. If your man machine material is used properly, then you can get a optimized part cost. Otherwise you are going to create a big mess for yourself and for your company. So that's why you need to do a perfect layout. Maybe not one time, you do 5 layout and pick the best one by your experience. Next page we discuss what are the factors affecting strip layout. Number one factor is shape of the blank. What does it mean? If a shape of the blank, shape of a part is very regular size, a circular size, rectangular size or a square, so you need not to go for a very complex tool making or complex strip layout, or may not need a strip layout at all. You can go for a simple cut off tool. In case of irregular shape, a profile where you need to have, you cannot place it very easily, so in that case need to put your component in perfect strip layout and check the effective utilization. Number two is production requirement. Imagine you have 200 pieces or 2000 pieces, and another case you have 2 million pieces, so your approach may not be the same. Your approach will be different, your strip layout will be different. You may not go for one component at a time, you can have 4 components at a time. You will attempt for a 4 component, sometimes multiple components in one stroke, to improve your productivity or to meet your volume. So production requirement or volume or numbers, quantity plays a very important role for deciding the strip layout or tool design. Number 3 is grain direction. What does it mean? The strip comes in a rolled form, so imagine, always remember the grain size is along the rolling direction. The grain direction always follow the rolling direction. So imagine you have a component like this, a bending component. Always remember a bending profile. When you have a bending profile on a component, there is a chance of spring back. So always in the direction of grain, if you go to bend your component, there is a chance that the component will spring back. So it depends upon the requirement of the part. If the part need to be stronger, then you have to accept the spring back and use the direction of the grain. I mean, your bending direction will be against 90-degree, the red direction of your bend direction. So if the component have no strength requirement, you can compromise with that. You can put your component along the directions. What is called boss side? It's a very typical factor for component quality. Friends, when you go through different cutting operations, please remember during cutting you are going to get 2 parts. One is useful part, one is scrap. Sometimes your piercing hole or a hole is your actual part, or sometimes your slug, which is called a blank, that is the actual part. If you see the slide, this is all about a piercing hole where the rollover radius comes on the top, that is a burnishing band, then the fracture, then bar comes on the bottom side of the sheet. When the hole is important, you have to consider that bar will come against the cutting direction. But go to the next figure. This is a blank, this is just opposite. your rollover radius comes on the bottom side, burnishing band will come on the bottom side, fracture will come on the upper side, and your boss side will come on the top. So when you decide the strip layout, you must check which part is going to be useful, whether you are going to use the piercing one or the blanking one. So need to analyze the drawing, and in the drawing it must be clearly mentioned how to use your burr, because if there is burr, you may not use the part very effectively in the assembly. You may have to clean it, or sometimes sharp edge is not required. So a lot of factors involved to both side. So this is a factor a designer has to look into when he design the strip layout. Number 5 is stock material. What does it mean? Stock material, it can be ferrous material, it can be non-ferrous material, it means it can be copper, it can be brass, it can be steel, it can be hard steel, it can be wood, it can be plastic. So what kind of stock material you use? If you use a very costly material like copper, brass, or something, enconel, different costly materials which are used for electrical automotive applications, so a designer has to be very careful about how to save material, how to save the scrap. So it's very important to understand or to learn or to see the drawing, what are the materials or what is the stock material actually used for this part. So it will have a lot of impact on your strip layout. We will discuss these things later. So next factor is your economic factor. The designer should try out every possible means to attain a minimum 60% usage of strip without sacrificing accuracy of the piece part. What does it mean? When you get a strip, you make a layout and try to get a part out of it, you are not going to get 100% strip utilization. You have to leave something as a scrap, and it doesn't mean that your scrap percentage is greater than 40%. Sometimes the designer, most of cases, people, they don't spend time, they don't analyze, and they make a design such a way that the scrap percentage will go more than 50%. This is not acceptable for a tool designer. This is not a good economy factor for tool design. So must check lot of factors how to minimize your scrap percentage. The bare minimum useful factors is 60%. So the below formula, economy factor, how to calculate area of the blank is number of rows into 100 and width of the strip and pitch. It's a very simple calculation. If you practice, you can go into, you will get to know how it works. This is a strip, and check for your information, the black portions are all scrap. Right side, if you see, I try to explain you in a picture mode how the strip layout affect the utilization percentage. The top portion is the component, the first row, the percentage is 56.5% because the component is just placed. It has not intelligently placed on the row. So the percentage is 56%, 56.5%. You go to the second row, same component but placed intelligently by a designer, and you see the designer place actual bridge, it maintain a side bridge 2.5, and the pitch also reduced, so total utilization factor is improved and it has reached up to 73.5%. So what does it mean? So economy factors, it's not a constant factor. You have to keep on working, keep on analyzing the strip layout, placing the components so that your utilization percentage will go beyond 70% or 60%. Again, economy factor, you see there are some examples. Same example is repeated here, 56%, 73%, and another layout you can check here. Same component when you place a single pass layout and same component placed in double pass layout, the utilization percentage is different. One is 56.5%, one is 73.5%. Again, economy factor, I tried to show you one more strip layout. Friends, look at the strip layout here. The component profile is not uniform, it's very typical. It's very difficult to design a strip layout for this kind of component. This component, even you try all the options, it's very difficult to save the material inside. The scrap percentage, it will be 40 to 50% of utilization. So the designer here is cleverly placed a small child part. So to use the strip, the designer put two child part in the scrap area to use the strip to its maximum utilization level. Same way you can see the designer tried to put two components according to applications. One is if the applications is different, if the component is going to bend afterwards, so they can put in two way, but here they try to show this is the best layout for one tip bend. Is the left one or the right one, is the positioning of the right one component is not good along the grain direction. So next you see the nesting here. If you get a component like this, you can put in a zigzag manner, angular manner, or in a nesting way, so that you can save lot of scrap. Here the strip looks like it has used its maximum. What are the strip layout terminology? See the right side, there is a strip layout explained as a black strap, black scrap and scrap bridge, pitch, front scrap, width, length of the strip. What's called pitch? Pitch is the distance between two conjugative operations on a strip. When two components will be pierced or blanked, the total distance travel is called pitch. Similarly, scrap bridge is, this is the portion of the material remaining after blanking, operation between one edge of the strip and the cutout portion. Front scrap, this is the scrap bridge on the edge of the strip which is towards the operator. Back scrap, this is the scrap bridge on the edge of the strip which is away from the operator. Next is we can go to type of the strip layout. One is single row, single pass. There are different type of strip layout. You go one by one, then you will have a conclusion. Single row, one pass layout. You see one component. You can place this component in a length shape, or you can put same component in a width shape. Okay, the top one called narrow run, the bottom one called wide run. Okay, but the question is, when we select narrow run and when we select wide run, which is advantageous, and when we should choose it? Wide run advantages. When you go for a strip positioning in a wide run manner, you have lot of advantages. Imagine every advancement of the strip, it takes time. If you allow the operator to feed a longer distance, so definitely it will take more time. So if you spend 1 millisecond or 1.5 millisecond for feeding one component, it will be multiplied in millions. So if you save that time, it will save a million milliseconds if you place the strip in wide run method. So the first one, you see wide run advantages: shorter advance distance of the strip feeding. Your advancement of strip is very short, so you save lot of time. More blank could be produced. If you use your production hours 8 hours, in 8 hours you can produce lot of components if you save your feeding time. Number of strip, your strip used to come 1 meter, so if you feed like this wide run method, you save lot of strip. Handling time will be less, but there is advantage of narrow run. When there is a special requirement of a component strength and it related to your grain direction, then you cannot compromise it. You have to go for narrow run method. So type of strip layout: cutoff and notching. This is cutoff and notching, where you need not to go for a full blanking, full cutoff outside profile. You can just have a notching punch, have a piercing punch and cutoff as shown in the strip. Parting up. Here parting up, you can have piercing, you can crop it and then parting it up to get profile on the external surface. Similarly, trimming and cutoff method. This is called double pass. So you can put a strip in a double pass way so that you can save. Double pass means you can feed the strip, cut one component at a time, then reverse the strip and feed it again, so you got another component from that strip. This is called double pass method. This is also strip layout. First row, you see your strip width is less and it's a single row, and second one is your double row, your multiple row. You can get 5 components, 3 components, 1 component, depend upon your volume. If your volume is very high, then you have to make a complicated tool. You cannot consider only the cost of the tool. Here you have to see the output also. You may have to go for a multiple layout, have multiple die profile, punch profile, and you will get more components in one shot. Another option is your gang punch. It means you have 2 row and you have 2 punches. You get 2 component one time. What is a gang die? A gang die consists of 2 more similar set of tool numbers has to produce 2 or more components during a single stroke of the press ram. A gang die eliminates the cumbersome process of double pass. The higher tool cost will be offset by higher rate of the production. Here your tool cost may be higher side because you are using 2 set of die and punch, but at the end, when your production or productivity is higher, it will surpass your investment. So when your volume is very high, you are saving lot of scrap, so you may consider in that case of a gang punch or die. Gang die are not recommended for very complex work. Why? When the component outer shape is very complex, you cannot afford to have a 2 set of die in one tool. It will be double the cost of the tool, and handling cost will be very high. Tool maintenance will be high. If the tool have one breakage, you have to dismantle the tool and your downtime will be very high. So selecting a gang punch or die depends upon the complexity of the part and the volume requirement. Friends, this is where I try to show you a small example. See the component shape and how the strip layout is and what is the steps is explained for your basic informations and how a progressive tool look like it, just to give a initial idea how the press tool or tool look like after production. Thank you.